Okay, yes, I actually remember reading classes. Anyways. Before you started, any questions or issues? Learning Suite had the demo scheduled for next week, which didn't matter much, but the demo's in 2 weeks. The demos are in 2 weeks. Midterms in 3 weeks. Someone asked about the time, and I'm going to do the midterm review, but the midterm will basically start 5 minutes after midnight, Monday morning. That's actually a tradition that got started a few years ago because I had someone who was in London for Thanksgiving. So I was starting it early for them. Basically 24 hours from midnight to 11:59 p.m. Monday night. We'll talk more about that in a minute. Any other questions? You all excited? You're all ready to show something in 2 weeks? Mm-hmm. Yeah. Okay. Let's talk about the midterm. We'll do another review of the midterm review in 2 weeks, but just to get you thinking about it. It's online, it's Learning Suite. No, there will not be class today. You can take it from anywhere. It'll start, but you'll have a 3-hour time limit once you start. So you want to make sure you've got 3 hours blocked out. It'll open at 5 minutes after midnight on Monday, and we'll close at 23:59 the same day. Open book, open note, open device, open internet, but your own work. Yes?
I'm guessing that means start it before 9 p.m. Otherwise, it'll close up before 3.
I'm not entirely sure. I think if you start before 11:59, it'll still let you go for 3 hours. But I haven't tried to test that out, and I haven't had feedback from students one way or the other. But yes, I would advise, just to be safe, starting it before 9 p.m. I often have a question about life cycle deliverables. But not always. There'll be 5 questions, each worth 25 points. It'll be 125 points total, and it'll be 25% of your class grade. You have to get at least a 60% to pass the class, and I think in 5 years I've had one student who actually took the test and scored less than 60%. Here's a little clue, as you'll see. If you put anything down, you get at least 1 point. You know, even if you just say, if it asks for 5 things and you say, I don't know on 4 of them, you'll get 4 points for that. Leaving it blank, you'll get 0. So write something. Any questions so far? You've already been, the questions, now you guys should have finished, you all should have finished, your quizzes for Mythical Man Month and for Peopleware. Some of you may have looked at, possibly not finished yet, the quiz for Facts and Fallacies. The questions there are quite literally adapted questions from prior midterms. And the answers are the same sort of answers. Now with the readings, it asks you to make citations from the book in question. Here you can cite from anything, and we'll talk about what the anythings are. Well, almost anything. Class sources. Yes?
I had a question about, it just totally went out of my head the moment I opened my mouth.
Okay, well just raise your hand again as soon as it comes back. Here are your sources that you can cite from. Mythical Man Month, Peopleware, Facts and Fallacies. And this, by the way, includes chapters that were not assigned reading in Mythical Man Month. I often have people come back and cite stuff out of those chapters. Oh, you remembered, yes?
I remembered, yeah. What's the approximate length of answers you're looking for?
You'll see in just a second. I'll have a slide here that will show you sample answers. The Armour, Meyer and Rectin, the Webster readings, you can even use the extra credit ones if you want, and my in-class lectures. Now, I will say don't use my in-class lectures as a shortcut because you don't know where the site is within, say, Mythical Man Month. But there are things I say over and over again. You know, things like as you have heard, the only way to manage your schedule is to drop features. That isn't in any of the books, at least I think not that explicitly, but you can do it. You can cite the podcasts. So, this is the whole idea here, and the whole focus of this class is that when you get out in the real world and you encounter these problems, you say, oh wait, DeMarco and Lister talked about that somewhere in Peopleware. And you go flipping through and say, oh my gosh, look at this, I'm in trouble. We were just having this discussion before class about what happens when management, demands features and, you can't deliver it well, and it's going to be cruddy, and as one of our fine students here said, sometimes it just drives the good people away. And trust me, it happens. I've left companies because I was unhappy with the management. Fortunately, it didn't happen often, but it can happen. Any questions here? And again, we'll go over this again in 2 weeks. Just trying to get your brains ready. Okay, great. And by the way, these slides are already up on the website. In fact, I actually posted them last week. This is a great slide to print out and have handy, because this is the ultimate cheat sheet here. It tells you where to look at. Within Mythical Man Month, look at Chapter 18, table of contents for both Peopleware and Facts and Fallacies, the root page for the Pitfalls, Webster 6 that you're reading now, and then just go to the online readings list, the lecture slides, and so on, and whatever notes you have. These are places that you can go to if it's like, okay, I know Brooke said something, go look at Chapter 18. Because it basically gives an outline of everything he's said up to that point. It's like, oh, that's where he says that. That's in Chapter 4. Let's go to Chapter 4. So, now, I'll continue to say this. While you're working on a test, always compose your answers locally. I really recommend using a laptop or something, relatively stable. Make sure you've got power. Make sure you're not going to run out. Compose your answers locally, and when you're happy, copy and paste them into Learning Suite. Learning Suite works fine about 95% of the time, but I have 1 or 2 students every semester who, lose, and I end up coming, they call me up and or they text me and they're really upset because they just lost 2 hours worth of work, thanks to Learning Suite. You must cite from at least one of the class sources where a citation is asked for. Feel free to cite to the lecture slides, but if it's simply restating a class source, you must cite to the source. Forms of citation vary by source. This is hard because I know a lot of you have electronic copies, and so you really don't have consistent page numbering and so on and so forth. But I want you to identify at least the chapter you're citing to. With Facts and Fallacies, it's easy because they're all numbered. But with Peopleware, with Mythical Man Month, cite to the chapter. And the basic score, and we'll go into this in more detail. Long as you have an appropriate citation and what you're actually talking about there. It's not just you can't just say Brooks Chapter 2, it's Brooks Law, Brooks Chapter 2. That's an 80% answer. So, important test taking thing. Don't get hung up trying to compose a lengthy answer. You're all seniors in college, you should know this stuff, but go through and answer the stuff that you can answer quickly and off the top of your head or with very little time. Because I do have, usually, I'll say 5 to 10% of my students each semester get a less than stellar grade because they spend too much time up front and they end up towards the end of the test running out of time to post answers. Go through, read all the questions, get the answers out of the way that you can answer quickly, and then go back through and start to the extent that you need to actually look through, look citations up, or If you look at it and say, I have no idea what he's talking about here, that shouldn't happen, but you may say, I know I read that somewhere, but I can't remember where. Okay, get that, move on and answer the ones you know. Then go back and start looking. Any questions here? Yes?
Yeah, I guess maybe you answered this, but for the omitted chapters articles, do the extra credit readings count?
Sure.
Okay.
Sure, extra credit readings are fine. What I'm trying to do, I saw someone asked a question on Quora about a week and a half ago, and said, are there any software developers who have ever read a book on software development cover to cover? And one person answered and said, yeah, I've been programming 40 years, I've never read a book cover to cover. And I thought, that's not something I would post publicly. But it does reflect the reality. And my goal in this class is you come out of here having read books cover to cover. And as I told you, very first day of class, you'll be ahead of 90% of the industry. Okay, for a given answer, you have to use, thank you, all of you who recommended laser pointer. Okay, except I keep expecting to show up there. The missing 0 point. Inappropriate answer, you can say I don't know and you'll get 1 point. Or you can say, well, I think it's this. And you may get 2 points out of it, okay? You really might. If it's like, well, I know it's this. Now, if you have an unspecified citation, or just a citation without an explanation, or an explanation with no answer or the wrong citation, you can get 3 points. That's a C. So you say Brooks Law, but you don't say where in Mythical Man Month it is. You get 3 points just for that. 4 point. Citation with some detail. Adding people to a late project makes it later. Brooks Law, Mythical Man Month, Chapter 2. That is a B answer. That is an 80% answer. And frankly, if you walk out of here and you can answer all your questions at that level, again, you're ahead of 90% of the industry. Now, if you want an A, you're going to have to really know your stuff. So this is where it pays off if you've taken the time to really read and think about what you're reading and understand it and so on. This is a long answer. Frankly, if you do 2 to 3 sentences along this line, and again, it's a correct citation, you'll get 5 points. And this is purely arbitrary on my points, so you're just having to impress me to show me that you actually understand stuff. Now, I will say, oh, by the way, I occasionally am so impressed by your answers, you get an extra. You can get 6 points on an answer. It's like, this person, yeah, they get this big time. Don't spend a lot of time because, you're going to be, if you're answering like that, you're probably going to get an A anyway, and you don't want to not answer the questions. But just be aware that when you see you get 6 out of 5 points for a particular answer, it just meant I was impressed. It's like, yeah, you really get this. This explanation, by the way, will be at the start of the midterm itself, so you don't have to memorize this. This is at the same text is at the very start of the midterm, so you can always refer back to it. Any question on this? It's hard. You really have to check out of the class to not get at least to be on the midterm. And the average midterm grade is like, I want to say 94, 95 typically. If you've been attending class, if you've been doing your reading, and especially now with the changes I've made where you've in essence been practicing this in answering stuff for the readings. The midterm should be easy. My goal here is not, my goal here is to get you to learn the stuff whether you want to or not. I don't grade on a curve. It's not here to see, I'm gonna, just really be flunk all except the top 10% or whatever. That's not it. My goal here is to send you out into the world with this stuff in your bones. And so when you start to see it in your jobs, you can say, oh, we talked about this in 428. And again, and this is not me, this is a reflection of the material. I get at least once or twice a semester emails back from former students who basically say, it's all true. Everything you said in 428, everything we read about is true. It's one of the reasons the department seems to be happy to keep me doing this. They just asked me to teach again for fall and winter next year. Because the feedback they get from the students is along the lines of, this was the most valuable class I had from the computer science department. And it's not because of me, it's because you're reading the materials that will best prepare you for actually working as a software engineer. Any questions on the grading criteria? I mean, you should really, if you, and by the way, I'll get to you in a second. And I'll say this up front, and you may see comments from me. If you're trying to fake it, I can tell. You know, I'll have an answer, and I'll see someone pull something out that's not really relevant, or it's clear that they're trying to sort of, wing it, and maybe if I cite this, this might be it. Worst comes to worst, you get at least 3 points on that. And frankly, if it's anywhere related, you're going to get at least 4 points. So yes, someone had a question. Yes.
So the max time is 3 hours. Do most people take that 3 hours, or do most people take less?
My experience is that most time is between 1.5 to 2.5, depending on how well you know the material and how well you think on your feet. You'll actually be better prepared than most classes because of the change I made to the reading assignments. It's going to feel like, oh, this is the same thing I was doing in Learning Suite anyway. I occasionally have students who go to 3 hours, and if you have either any reading difficulties and or technical difficulties or unexpected interruptions, just DM me on Slack. I will be monitoring things on Slack, and I can extend your time a little. So, sample questions. Okay, these are the questions. I mean, these are pretty much the same questions you've been looking at. So, the difference is instead of asking for the book, it just says something like this. Oh, that should, for 1 point. That should actually say for 5 points each. List up to 5 issues or recommendations that you consider relevant to it. And I think this was the one I had associated with mythical mammoth. So you should already be familiar with it. Likewise, this is the same one. And the difference here is instead of just citing from Mythical Man Month, we're just citing from Peopleware. You can cite from anything. Any of the readings, any of the slides, so on and so forth. Same thing. So that's Midterm. Any questions? Yes?
I'm curious what would be like a sample answer to like one of the sample questions.
Oh, that's actually a good question, and
Those are all those other questions you've been asking.
I have it right here. So here is a A-level answer, and this is a really, this frankly would probably get 6 points. That's a very extensive one. The B-level answer, the 4 points, is the one up there that says adding people to lay project, basic layer, Brooks Law, Mythical Man Month, Chapter 2. That'll get you 4 points. That's it, you're touching on it and saying this is this. Now, here's an explain what, doubling development staff. This is an example of a expansive answer. Frankly, I'll say, 3 sentences is enough to get you an A. If it's actually relevant, it shows what you mean. And like I said, if it seems really on point, you may get 6 points, which is more Typically, in my experience, people who end up getting 6 points on occasional answers are usually getting 5 points on everything else, so they end up like, 102% on their midterm or whatever. By the way, I'm curious, and I haven't looked at learning this week, has anyone taken me up on the extra credit for the Adventures of Bucker Bonsai? Oh.
Soon.
Come on. Okay. Let's, any other questions? Okay, let's cover the, sorry, I need my glasses. We will cover this, we will take roll, and we will be done. Like I said, the lectures get shorter and shorter going forward. Okay. Unstable requirements, which is actually what you were just asking me about. Scope creep, unstable requirements. This is such a big cause of runaway projects where you just have people continuing to add features or expand on existing features. And by so doing that, you introduce more invention. So we're back to armor. You'll hear me quote armor almost every class period. You have more ignorance because you may know how to do things and you may not know. If you know how to do something, so yeah, that'll be simple. Always be careful. The engineer's credo is under promise and over deliver. When they say, could you add this feature, say, even if you know literally the one line of code that you have to go in and change, say, well, I'll have to look at that, I'll get back to you. This is important for two reasons. One is it may be more than one line of code that you have to change. Or that changing that one line of code breaks something else and you suddenly realize that there's going to be some re-architecting or something here. The other reason is if they get quick answers from you, it's like, oh yeah, I can do that. Oh yeah, look at this. Hey, look. I just changed this line, checked it. Oh, great. And here's 10 more features we want you to add. You can do them just as quick, can't you? So, I'm not saying be dishonest. I'm saying under promise. Say, okay, I'm going to have to look at that and let me, try some things and test some things out, make sure I run tests, I'm not breaking anything. Anytime you change code, you run a certain percentage risk of breaking something, introducing new bugs, reawakening old ones, or whatever. And the line which I've already talked about, we want it to be just like the old system, but better. You will run into this at some point in your careers. It's like, well, no, to make it better, we have to change it. Well, I know, people hate change. We don't want to do things differently. Any questions on unstable requirements? This is fact of life. Yes?
Any suggestions on how to make requirements stable?
Yeah, reduce them. Group them according to your orders of ignorance. The stuff you absolutely know how to do, the stuff that you don't know yet how to do, but you know what you need to do to figure out how to do it, and the stuff that you look at and say, this is a landmine. If I step on this, it's going to blow my foot off. I'm going to approach this very carefully and figure out what's going to be done. So there is a, Brooks calls it gutless estimating. You have to be brave enough to say, I don't know. Or to say, we'll have to do some investigation first. Frankly, in my opinion, the best software estimation scheme is, to a certain extent, what you're doing in this class, which is you're getting your demo to an initial demoable version, And I suspect most of you have dropped features that you originally thought you were going to have in your initial demo. Congrats to those who haven't had to, and special congratulations to those who said, oh yeah, we got all this working, let's add this. And then you may find it's difficult to add any new features for your second demo. You have to push back, and that's hard. And sometimes you'll be threatened. You know, we're going to demote you. We're going to take this project away from you. I don't want you to leave this class thinking that every workplace as a software engineer is a nightmare. There are wonderful workplaces. There are places that really do things well, do things intelligently. But the part of what I'm trying to do here in this class is to sharpen your sense of smell. So that when you're interviewing or when you're actually working, you say, oh wait, I see this, this, and this happening. This is stuff I read about in 428. I know what comes next. And then you have to start making decisions as to what you're going to do. Sometimes you just live with it and you put in your time and do what you can. At General Dynamics, my first job out of college, I was assigned to various projects, and one was doing analysis of radar signals to try and distinguish between tracked and wheeled vehicles for a potential defense contract. And I was very comfortable with the work I was doing, but the engineer, this radar engineer I was doing the work, programming work for, was a very type A, whatever thing, and he was getting increasingly frustrated because I was working 8 to 5 and getting my work, and did not seem to have the level of anxiety and go-to-itness that he wanted me to have. And he complained to Tom Reed, who was my actual manager as a software engineer. I said, Tom, I'm getting the work done. I said, I know he wants me to work buku hours and so on. I said, but I'm on a salary. I'm not getting paid by the hour, and I'm getting the work done. And I actually did get the work done, and I got the work done on time, and the engineer was gracious enough to sort of mumble a semi-apology when he realized I actually did know what I was doing, and that I actually was getting the work done in a timely fashion. But it is the nature of the beast that quite often management does not understand the realities of software development. And frankly, quite often your peers don't understand the realities of software development. There's a lot of unqualified people out there working as software engineers, working as team leaders, working as software architects, working as CTOs, working as CIOs. And so a lot of what you have to do is to reason. Chuck started this class, the reason I continue to teach it is to give you the tools to see what's happening and to recognize what you can do to make a difference, and to recognize occasionally you just have to grin and bear it, and sometimes you just have to, pull the ripcord, jump out of the plane. I've done both. Okay, we're moving right along here, slide 3. Requirement errors, you want to find them as soon as possible. This is back to one of my favorite maxims I quoted the first day from Robert Spinrad. In architecting a new program, all the important mistakes are made in the first day. Best time to correct fundamental defects in requirements is when they are still just requirements. And that requires taking the time to think them through and what their implications are, and whether or not, again, we're back to sorting it in the ignorance buckets. I know how to do this, I know we're going to have to figure out how to do this, and these have things that I'm sure there's stuff I don't know yet. If you're going to reduce requirements, take them from the third bucket. That's how you manage it. You want to take them from the bucket where it's like, I'm sure there are things that I'm going to have to learn how to do, but I don't know yet what they are. Because that reduces your uncertainty. If you take them from the first bucket, you're basically burning the easy stuff. And once requirements get baked into architecture and then into design and then, heaven forbid, into code, that's the hardest time to fix those flaws. This gets back to the Webster reading on do not defer the difficult. If you defer the hard problems until you're well into development, what happens is you suddenly discover that you either don't have a solution or that you have 2 or more hard problems that have solutions that are mutually incompatible. You have to go back and rethink things. Any questions or issues here? Okay. Missing requirements are the hardest to correct because there were things that you didn't think you were going to need to do. It's like getting all the way into production and someone says, oh, by the way, all this processing has to take place in a 30-minute window each night. And you suddenly stop thinking, none of our design, none of our architecture, none of our coding assumed that we had that window. That's something that you would, I think, flush out. But it's that sort of thing. A requirement that isn't there is the hardest thing is to have new requirements show up when you're already at a coding stage. And as the slide mentions, a 25% increase in problem complexity, which is what happens when you add new requirements, results in 100% addition to the solution complexity. Requirements explode. Any questions? Comments? Speaking of explosion, you all did requirements documents. I suspect a lot of you found that when you started moving from your requirements document to actual design and implementation, you suddenly discovered a lot of other requirements that were there. It's like, well, if we're doing this, that we have on this high-level architectural level, then it means this, 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 and this. We have to do this, we have to live with this, and so on. This is a very common problem, this explosion. I see this in a lot of failed projects where the initial requirements list was relatively short. I won't say simple, but was short. But when they actually tried to move to design and implementation, it suddenly became very long. Because you had to say, well, it's got to do this, it's got to do this, it's got to talk to the system, it has to do this. And nowadays, most systems under development do not exist in isolation unless you're doing embedded systems. You're almost always interfacing with an operating system, with any number of libraries, with other applications, with data feeds, so on and so forth. And this is also where a lot of the requirements will come in. And then you discover that all these external systems you're having to work with have their own defects and problems. And so you have to, how many of you had the experience of having to code around a bug or defect in a library or an operating system or whatever? What was your experience?
I was in Flutter. There was some user-built libraries that were distributed for managing global state, or not quite global state, but sharing state across the application, and it was borking some of the built-in functionalities of being able to hot reload UI elements in the IDE. So we had to do a full shutdown of the application and full restart to get it to clean its state.
Yep. Okay. There's a future lying ahead of you. There's seldom one best designed solution to a software problem. The quote there by Bill Curtis, in a room full of top software designers, if any two of them agree, that's majority. And this gets back to preferences, experience, what you want, and this is what works against, not necessarily against, but this is the counterpoint to having conceptual unity and why you want to have an architect. Because the architect is often the one who will be presented or will come up with multiple design solutions and have to basically negotiate with the team and say, okay, you think this, you think this, you think this, we're going to have to agree on a particular design solution. And as he points out, this is a problem on trying to use component or automated software creation, the sole thread of AI, because it's going to have some canned design solution that it uses, which is not going to be optimal in all situations. Design is complex and iterative. Yeah. Basically, you're going to say, yeah, this is, I think this will work, and you'll get partway into it. How many of you in your projects have started off with an initial design of your software and then had to come back and say, no, we have to change this because you've run into a problem with the technology you're using, or it turns out that you can't actually accomplish the features you want in your thing? Anyone? Cool. You're all brilliant designers. Design tends to be mental. It's kind of like, how do I do this? How do I do this? How do I do this? What are the implications? Coding. Of all this is probably the most important part. It's easy to implement your own design. If someone else hands you a design and you start to implement it, there's a good chance you're not doing it the way that they would do it. It's actually very hard, if I'm a designer, for me to describe my design in sufficient detail so that when you implement it exactly as I would. I may have unspoken assumptions about my design that I don't even think to elucidate, or I get lazy. It's kind of like, we'll just do that. I'm sure they'll pick the right course. And you find this disconnect. This is why, in my opinion, chief architect needs to be hands-on with the code. And I see situations where the chief architect sort of sits in her or his office and thinks great thoughts and hands stuff out to the peon developers, and it usually doesn't work because the architect does not seek to enroll the developers in that conceptual unity and does not listen to the feedback as to whether or not the architect's grand ideas actually work. Cobalt. Cobalt. I actually am working on a case that involves Cobalt. There's 20 billion lines of Cobalt in production. That's the figure commonly cited. There's a lot of 50 to 60 something programmers who are making a lot of money helping to maintain Cobalt programs. If you're lucky, you'll never have to touch Cobalt. It's an ugly language. Any of you actually coded Cobalt or had to read Cobalt? When I was an undergrad, so we're talking not quite 50 years ago, about 45 years ago, the department had a small library and there was a book there on programming in Cobalt, and I took an afternoon and read the book and decided if I ever ended up with a job that required me to program in Cobalt, I'd be fine. And fortunately, I never did. But languages hang around forever. This isn't an important thing to know. You're not having questions about Error removal is most times, this is back to Brooks, 50% of the schedule, Glass says 40% of the schedule, some would say 30%. Management usually thinks it's 10%. And that's the problem. People who actually analyze the amount of time you spend fixing bugs, tracking and fixing bugs, say it ranges from 30 to 50% of the total time to get something into production. And management thinks it's going to be 10% of the time. Yes?
When it comes to stabilizing a project, we've talked about some models for the testing cycle, and it's generally been recommended to have testing incorporated throughout the development process.
Yeah.
But taking, say, I don't know, Debian as an example, they have a freeze date after which they do basically a whole bunch of rigorous testing to get ready for an actual release. Do you have any thoughts on how long that frozen, rigorous testing period ought to be for a release, for the sake of scheduling and management? Or does
But my short answer is no. My slightly long answer is you want, I am a, though I don't have direct experience with it, I lean towards the arguments for CI/CD, continuous integration, continuous deployment, highly automated testing, with the caveat that automated testing doesn't mean your testing is any good. I had a student, I mean, we talked about this in class about a year and a half ago. One of the students said, raised his hand and said, I work at a place that has automated testing. He says, the test suites are bad. He says, you know, it's nice that they're automated, but they're still missing a lot of errors. The flip side, and this is from an era of more heavy methodologies. My first consulting job after Page was closed at Eric, which is doing the network management for the Iridium satellite system. I was there to basically come up with an architecture because they didn't have one. We just had some design diagrams and to help them make the transition to object technology and so on and so forth. And the company had this very rigorous methodology which was designed for like a monthly or 2 monthly release schedule. So it's kind of like you had to do all this stuff, and then you had to freeze the code, and you had to go through this and have these reviews and come up with the tests. And then you had to do the testing, and you went through and evaluated the testing and so on, and then you'd release it. Well, the company, seizing on what was then one of the fads of the day, sort of a precursor to CI/CD, said, we want to do code releases weekly. But they're still trying to follow their methodology. And I pointed out they had a person in charge of their process. And I said, you basically have 1 day for programming each week. You're implementing this methodology where you have a day of review, you have your coding, but then you've got the post-coding review, and you've got the testing and then the release. Said each of those take a day. Literally, the way you're running, your methodology, your programmers get to program 1 day out of the week. And I said that's not working. They basically touch their code once a week. There are other problems with the whole project. They had 30 developers, and I came in and said, the 30 developers, I thought, boy, this must be a really big project. I said, how much code do you have? And they said, I think they said 14,000 lines of code. And I wrote about 50,000 lines of code myself. They just get 30 programmers writing 14,000 lines of code. You don't have conceptual unity. You basically have 30 programmers each responsible for about 1,500 lines of code. And they had no chief architect, so. So, I mean, back to your question. You want to automate it and you want to integrate it as much as possible. The problem you get is where you have a longer cycle and the testing is something that's done at the end of the cycle. You're doing your testing like, once a month. for 3 or 4 days. And that you lose a lot of feedback there, and you actually have a lot of opportunity to introduce errors. Yes?
So what I'm getting from you is that you'd recommend, in the ideal, continuous integration where you're relying on the completeness and correctness of the test suite as well as whether it compiles.
Yeah.
And if it passes those, then it's safe to ship.
Well, it's safe to put it in production. Now, you may have a different gatekeeper who looks at it, and again, I run into stuff like this. Facebook is stabilized a lot, but in the earlier days of Facebook, it was not common to have. I once logged on and suddenly everything was in Portuguese. And you'd have them change. It was clear that changes had been checked into the code and pushed out to production and had not been sufficiently tested. I think they have better gatekeeping at this point, and perhaps better tests. But the idea is small changes, because that you have a lower chance of interesting defects. As extensive testing as you can get, as automated as testing can get, so you're not relying on humans, and just try to have a production system on a continuous or near continuous basis. It really is, and this is the book Accelerate, which again I recommend, by Forsgren et al. Because their recommendations are not based, well, I'm sorry, I'm interrupting myself. It's hot stack here. One of the things that Glass talks about is how much of what has passed for advice in software engineering is people thinking, this sounds good, so let's do this. He says, no, you have to have it actually based on research that shows it's good. It actually makes differences. Accelerate, the book is based on actual surveys of high-performing and less high-performing companies, and seeing what practices are adopted by high-performing software development firms versus the practices found in firms that are not performing as well. So I recommend the book for the practices listed there, because it's based on actual research from real-world development systems. And if I really wanted to be brutal, I'd have you guys read that book as well, but 3 books is enough. Testing, logic paths, it's really hard to get complete coverage. Even if you're going through all the code, you don't know that you've actually tested all the potential logic paths. You know, if I'm testing, if you've got a case statement, switch statement, that has 10 cases, you know, it can be difficult to write code that will test all 10 cases and test all other variations in the parameters. So this is why a lot of testing is sort of defining boxes in which you know the software is more or less stable, and making sure you're not exceeding the boundaries of that box. Good testing is an art. This is interesting. Even if you had, in theory, 100% coverage, you can have missing logic paths. In other words, this is the missing requirements. It's like, yes, we handle case A, B, and C, but by the way, there's also case D and E that can happen, and you're not handling that at all. It's not there in the code. And it's either defaulting to A, B, or C, or the code just simply blows up when it happens. Or you can have unique combinations. I mean, stop and think about astronomical is too small a term. If you stop and think about all the variables, all the data within a moderately complex piece of software, and the number of combinations of values that can exist within there, it is truly astronomical, and the only way you can bound that is to try and break it down and constrain things. Use tools. Coverage analyzers are great. Performance tools. I remember the first time I used a performance tool, it was like a revelation. It's like, oh look, come on, my code, it's the Pareto rule. My code is spending all its time in this this one section. Oh, that's why I'm doing this. Fix it. Oh, look, my code runs a whole lot faster. There are good software development tools, of course, again, debuggers, and a lot of my early coding experience was all before debuggers. So yes, having source code debuggers, I can step through, I can set flags, I can do that. Stuff that, sort of like baby's milk to you guys, was stuff that was like, oh, this is so cool. My gosh, never had this tool before. So, make use of the tools, make use of them appropriately. He wrote this in 2002. Test automation was pretty primitive back in 2002, especially in the 1990s, which is what he's really writing from a viewpoint of. They were mostly efforts to emulate user interface and so on. Testing tools are much better these days, and so make use of them. This is still my favorite debugging technique. Put in something to write out to a log, and run the code and say, oh, hey, look, that was the value that went through there. That is still often one of the fastest and simplest debugging techniques. It's simply to put some, put some code in there to write stuff out to a log file, or to pop a message up on the screen or on the console and say, yeah, I'm doing this, I'm doing this, I'm doing this. I don't do a lot of coding these days. When I do, I'm usually writing a custom tool because I'm analyzing source code or something. And this is pretty much what I do. And I'll be very blunt. It's very quick and dirty coding. I'm using Python or something and parsing stuff and Google. Okay, I've got all the files. I'm reading each of the files. I'm looking for this, and I stick a bunch of print statements in there in order to figure out what I'm actually getting and whether or not I'm doing it right. So don't neglect that. Rigorous inspection. Now this is why this was the benefit of pair programming. How many of you have actually done pair programming? I'm not sure I would have the patience for it. What's been your experience with it? Yes?
When you're doing it, like over Zoom or something, where you're like sharing screens, it's pretty awesome. If you're like next to each other, sharing screens, it's awful to like bump an elbow, like it feels like he's like staring over your shoulder, and it feels really weird, and I hate it.
That's actually, and I hadn't thought of the Zoom thing. Yes, it strikes me that Zoom would be far more effective for pair programming than the side by side. It's like, no, go away, leave me alone. I want my personal space here. And other experiences anyone wants to share? Yes.
It always felt like it took, 4 or 5 times longer than just doing it individually, but I was always a lot more confident in the code quality when doing it.
Now, Tom Affinito, I've quoted before, at Taligent, said at their Taligent, they had a practice that was sort of a end-of-day version of pair programming, which was that for their developers, at the end of the workday, you had to go find another developer and spend 20 minutes showing that developer all the code changes that you had made that day and why you made them. And he said this was very effective, both because it was like a mini source code review, and because if you knew that someone else was going to look at your code at the end of the day, you tended to be far more careful in your coding. And I think that's, actually it's up there, simple version, everything's on Affinito. And of course, the classic debugging technique. This is always my favorite debugging technique, is simply to try and have someone come into my office and say, I've got this bug, here's the problem. And I would almost always stop halfway through and say, never mind, I just figured it out. And some people talk about the rubber ducky, but the rubber ducky doesn't have the ego issue for you there. It's having the actual live person there and you think, oh my gosh, that's what it is. And you want to realize it before they point it out to you, so you've got that. Yeah, oh, never mind, go away. Because you don't want them to see the stupid mistake that you made. And this is a classic cartoon. Anyway, So, be kind in your code reviews. Postmortems, boy. Organizations a lot of organizations do not like postmortems, and they're important. This is part of why I got to be so good, if I can claim that, at knowing my projects failed, is because I have done so many postmortems on failed or disputed projects. I have read thousands of emails and memos. I have traced dozens of timelines of projects. And it's kind of like, when I'm called in as an expert witness for a disputed or failed project, I look for what I call the inflection point. And these are always like 2 or 3 party cases, so it's, a corporation hires an outside firm to develop or to implement or configure software for them, and at some point it ends up in a lawsuit because of typically repeated missed deadlines and so on and so forth. And they usually start off in alignment. It's like, yes, we can do this, yes, we can do this. And at some point there's an inflection where their interests and efforts begin to diverge. And that's what I look for. It's why I like, the 2 things I like the most are all of the emails in chronological order by the engineers, the actual developers. Because engineers are brutally honest. One of my first cases was a lawsuit between America West. They had a vacation planning division. They hired an outside development firm to develop software for them, and the project went south and so on. And I was reviewing the emails from the developers of the outside consulting firm, and you had one of the lead developers saying, I can't believe we're charging America West $100,000 for this garbage we're delivering them. And of course, the lawyers on the other side tried desperately to get that excluded, and like, no, that's valid discovery. The other thing I like is status reports in chronological order. Because as soon as status report stops changing, I know something's going wrong with the project. They're simply updating the date. Oh yeah, it's 90% done, it's 90% done, it's 90%. It's like, say it's 90% done for like 3 months. And the reality is that they've hit some core problems. They're desperately trying to debug and or re-architect. Yeah, code reviews are both technical and sociology. Boy, it's painful to have someone criticize your code. Actually, I'm sort of going through this right now. I have a friend who's a published author and an editor who's reviewing one of my novels. And he already came up this morning with some suggestions. Like, wait, no, that's there for a reason. It's hard to expose our work to others for criticism. It is. And all the way back, Jerry Weinberg in Psychology of Computer Programming, published 1971, tried to promote the idea of egoless programming, and everyone said, no, it's not going to work. And even Jerry came back and said, no, it's not going to work. Okay, that's chapter 2. Any other questions, comments, observations? I'm assuming, again, my purpose of these lectures is not to do the reading for you. I assume you've been doing the reading. Assignments, you've got a team status report that's due on Saturday. Read chapter 3 for next week. Keep reading Webster 6. We may delve, since I did a mini midterm review today, we may do some of Webster 6 next week. The demos and another midterm review and the rest of Webster 6 in 2 weeks. Midterm in 3 weeks. We'll have a lecture in 4 weeks. Lecture in 4 weeks will just be my, and I still have to take rolls, so don't jump up and around yet. Will just be, I have a standard lecture on legal risks for IT professionals. And then final demos in 5 weeks, and no final. No final. I hope all your regular midterms are going okay, because I suspect that's what you're in the middle of right now. Are you in midterms right now?
so that aren't midterms.